Good evening, Gautam. Anila, good evening. Beta, today a very important class of derivatives I am going to start. Shreya, good evening. Now look here. The first part of the class we are going to talk about derivative at a point. Now Pooja, good evening beta. First, to understand derivative you have to go to the basic idea of limits. Okay, because limits was exactly explaining a very important point, and that important point was कि whenever we are drawing a curve at particular point, I'm just starting. Kritika, good evening beta. Good evening Kritika. So now I'm just going to start a very important point, and from the beginning section we are going to understand about derivative and we are going to understand about limits. Okay, now Danish, good evening beta. So first important thing is I'm going to start with the basic information. I'm going to start with the basic information. The basic information is, like, right now we are going to study derivatives. We are going to study differentiation, differentiation or derivatives. Now differentiation or derivatives, from where it is going to be existed and how we are exactly going to find derivative at a point. Derivative at a point means differentiable at a point. Means when can a function be differentiable sorry, when can a function be differentiable at a point? So first we have to understand what does limit says about it. So what is exactly called as limit? Limit means if any function is given, a curve is given to you. Now I'm just wanting to check the limit in an open interval or limit at a point. So when I'm going to check limit at a point, I'm going to check that okay, the limit is existing at x equal to 3, then we are going to check the left hand limit and right hand limit. So we are going to check the left hand limit and the right hand limit. The left hand limit and right hand limit we are checking, and when we are getting left hand and right hand limit both, then we are finally saying that okay, the limit exists. The limit exists for that particular point, and if left part of the limit and right part of the limit is not existing, then we say that the limit does not exist. The limit that does not exist at that particular point. So you will be thinking that I'm talking about limit. Why we are talking about limit when we are starting differentiation? Then you have to understand the same point of differentiation is also having limit. Limit means what? If I am going to talk about this pen and I'll say that can I break this pen into some intervals? So you will be saying, yes auntie, you can break this pen into certain intervals, and then I will say that I will break the pen into certain intervals, and then I will be finding that at one particular interval, at one particular point, this will be existing or not. This will be derivable or existing or not. Means the left part of it will be equal to the right part of it. Will it be able to derivable, or will we be able to derive it or not? That is exactly an important point of derivative. Okay, so I have eaten so much of your brain. I know you might have not understood anything. So straight away I am going to go to the point. The point is कि whenever we will take any real valued function, what is a real valued function? First, to understand how many types of real valued function are there. All the functions like f of x equal to e to the power x, f of x will be equal to x square plus 4x plus 3, f of x will be equal to log x. Means different type of functions are there. Logarithmic function, exponential function, algebraic function, trigonometric function, they all are exactly called as real valued functions. Okay, so different type of functions are there. Now these different type of functions are real valued function, and they will be defined on open interval. Defined on open interval means what? Means each type of function will be having a graph. Okay, now you already know, when you have studied about relation and function, you might have seen that all the different type of functions are having a graph. Like e to the power x I am taking and drawing the graph of it. So e to the power x graph is this one. That means whatever real valued function are there, they are defined in the open interval. Open interval means what? Closed interval means what? Means open interval means there is no specific reason selection. But when we do a closed interval means कि now lower limit, lower boundary will be there and upper boundary will be there. So when lower boundary and upper boundary will be there, whatever point will be there, we are going to take from that point. Open interval also will be there, but after that we are not expecting any value between that. So we are going to take a point from the open interval. Okay, so for any type of differentiable part, when we are discussing, we will say that different type of functions will be there. Different type of functions like logarithmic function, algebraic functions, exponential functions, trigonometric functions, inverse functions, different type of functions will be there, which will be real valued. That function will have a graph, and that graph will be defined in open interval. That graph will be defined where? The graph will be exactly defined in the open interval. So that means the lower boundary and upper boundary will be there, and it will be defined in open interval beta. Then we have to take one point. Now where we have to take one point? We have to take one point in between the open interval. So that means this is the interval. This is the interval. Lower interval is coming as A, upper interval is taken as B. But this interval is not closed. This is the open interval. In this open interval of the curve, you are taking a point C. You are taking a point C. Now, you have to find that f of x is said to be differentiable or derivable. Means you can differentiate the function. You can differentiate the function at particular point C. Okay, so that means what? Now what is exactly differentiation at particular point means? Means I am going to break this pen into a small piece, and now I am going to check that the left part of it should be equal to the right part of it. The left part of the pen should be equal to the right part of the pen. That means this is derivable, or it is exactly differentiable, and it will be existing for left hand derivative also and right hand derivative also. So this is the common simple concept. Simple concept says that when a function will be there, it will be defined on open interval. Open interval means A and B you are not going to take. A and B point you are not going to take, but inside whatever values are there, that you are going to take, and in that what you have to do, you have to pick a point C. And after picking a point C, this function will be called as differentiable at that point at x equal to C if the function differentiable part will exist. Okay, that's why you see I have used the word limit here. That means at x tends to c, it will be existing. Means at particular point x tends to c, the function will be existing, and left hand derivative should be equal to right hand derivative. This is exactly a very simple and a very important talk. Like I have given you a thread. Just understand, I have given you a thread, and in that thread I have put a red mark, and I said that if you will go left of the thread, left of this red mark and right of this red mark, you will be getting the same value. Understand, I am telling a very important point. I am saying that I have given you a thread, and I told that I have exactly marked a point with red color, and I am saying that you differentiate the thread and go left of it and you go right of it. You break the thread and you go left of it and right of it, when you will be getting the same point. Means you are differentiable at that particular point. The thread is differentiable at that particular point. It is a very important point. Apart from maths, I am discussing this content. So here we have to understand a very important point here, that it will be differentiable or derivable at x equal to c if limit x tends to c minus f of c will be existing finitely. So it should exist. It should not be going infinite value. So the first important restriction is, when you will be differentiating any function, the function should exist and it should give you a finite value. The function should exist and it should give you a finite value, and it should be differentiable at particular point. It should be differentiable where? It should be differentiable at particular point. So there are many things, one by one I am going to explain. Now here, whenever you will be talking about function, the function left part, so always a derivable function will be written as d of dx. So when we are going to differentiate, we are writing it the function f of x d of x. So that means we are differentiating. What does this line means? This line is meaning that we are differentiating the function with respect to x. This line is meaning as we are differentiating the function with respect to x. This line means what? Differentiating a function with respect to x. But here the definition was about left hand derivative and right hand derivative, means center, left, right. It has to be existing at the 3 point. But for our chapter, what chapter we are going to do, they have already told the function is existing everywhere. So not one particular point, the function is existing everywhere. You see here, they told that throughout this chapter, we are going to assume that the function is differentiable at every point in its domain. You know that domain is represented as x-axis value. So whatever value of x you are going to take, the function is going to exist and it will be differentiable. The function will be going to be existing and it will be differentiable. Okay, and left hand derivative will be equal to right hand derivative. So left hand derivative part will be equal to right hand derivative part. So I think you have not understood anything. So now it is exactly going to be a waste of time if I'll keep on explaining the definitions, because I know that generally students won't understand the definition. They only understand one simple thing, that auntie, if I'm going to take this pen now and I'm going to break all this pen into 10 pieces, auntie, that means the pen is now existing in 10 different pieces. So that means we can differentiate a pen. In the same way, if I am going to take a curve and I am going to say that this curve equation is y equal to e to the power x, and then we are differentiating this equation with respect to x and it will get differentiated, means we have broken the curve into a small interval. We have broken the curve into a small interval. This is exactly called as differentiation. Okay. Simple, miss, I know that I have given a very big lecture. You might have not understood certain part of this lecture also. It will be a waste of time. So I am just picking the most important point. So if I am going to differentiate a function, any type of function, we are going to get a small part of it. We are going to get a small part of it. Differentiation means reducing the function into a small interval. Reducing a function into a small interval. A big curve, I just converted into a small interval. And then if I want to check that First what I did, I differentiated it, I got converting it into small interval. Now we have to pick a point in this interval and we have to say that is it going to exist in this small interval. If it is going to give left hand derivative and right hand derivative same value, means it is differentiable at that particular point, or otherwise the point does not exist in that interval. The point does not exist in that interval, the content is that only, rest other everything is bullshit, waste of time. Okay, so now we are going to use the formula. The most important thing is how to do the first order derivative, how to use it, that you should know. What is it, we will come to know after, at the time of solving. So how to do it, that is the most important point. Now the first question I told you now, we are going to take differentiable at all the points. So we are not going to take about one particular point, and left hand derivative will be equal to right hand derivative. You have to understand that derivative f dash c is exactly presented as what? Derivative f dash c will be written as limit x tends to c f of x minus f of c by x minus c. So that means this f dash c should be existing. Should be existing means left hand part. Left hand of the derivative should be equal to right hand of the derivative. Okay, so this left hand of the derivative equal to right hand of the derivative, but for this chapter they will not tell you to prove that left hand of the derivative will be equal to right hand of the derivative. This chapter you are going to take that ki left hand derivative equal to right hand derivative, you just have to differentiate it, or you have to just find the derivative. You just have to differentiate, or you just have to find the derivative. Only this a small work you have to do. Now it will be exactly going above your head, so no need to waste time and scare you from this chapter. This chapter is the most easiest chapter. Only you have to pick 2-3 important points and you will be able to deal with it very nicely. So some formulas are there. First you have to see the formula. The formula is, we know left hand derivative f dash c will be written as limit x tends to c minus f of x minus f of c by x minus c. It is exactly coming as c minus. You know, first term I taught you how to convert this interval into h. So what you have to do? You have to take let x equal to c minus h. So this is left hand part of the derivative. When c minus is written, that means it is representing left part of the derivative. Which part of the derivative? Left part of the derivative. It is representing which part of the derivative? Left part of the derivative. So now we are going to find the left part of the derivative. How to represent the left part of the derivative in h form? So first we are going to take let x is equal to c minus h. So see here, you see nicely x tends to c minus is there. So we are going to write let x equal to c minus h. Then we are going to write since x tends to c minus, therefore h tends to 0. That means now x is exactly, I taught you that time when I was discussing limit, I taught this interval how to do. Let x tends to x equal to c minus. So see, since x tends to c minus, therefore h tends to 0. For all h is a very small change. H is exactly very near to 0. At x is what? X is very near to 0. So now what we are going to write it now? Now limit h tends to 0. H tends to 0. So what we are doing here is we are converting this because we have taken x equal to c minus h. Now x is tending to c minus, so directly h will tends to 0. So h tends to 0. Now wherever x is there, now we have to remove x by c minus h. So now c minus h is there because x equal to c minus h. Here x is there. So now we are going to remove x by c minus h minus f of c. C will be written as it is. And then x minus c will become, see here, x is nothing but c minus h. So c and c will get cancelled. So left hand derivative formula will be limit h tends to 0, limit h tends to 0, limit h tends to 0, f of c minus h, limit h tends to 0, f of c minus h minus f of c by minus h. This is exactly the left hand derivative part. Okay. Now right hand derivative part directly I am writing. It will be written as f dash c will be equal to limit x tends to c plus f of x minus f of c by x minus c. This is exactly differentiable at point C. This is representing differentiable at point C. So when again we are going to assume that let x equal to c plus h, at that time this overall presentation will be written as limit h tends to 0 f of x. Now here x equal to c minus h we are going to put, so it will become c plus h. X instead of x, it will become c plus h minus f of c by h will be equal to 0. H will be there. So here this is exactly called as right hand derivative. This is exactly called as right hand derivative, and this is left hand derivative. So finally, but left hand derivative, every time what happens, we used to prove that a function is differentiable if left hand derivative is this one, that is limit x tends to 0 h tends to 0 f of c minus h minus f of c by minus h will be equal to this right part, limit h tends to 0 f of c plus h minus f of c by h. So that means left hand derivative will be equal to right hand derivative for point C. So the center point is taken as C, and this is exactly the curve. So left hand derivative will be equal to right hand derivative. For which point? For C point. So this is exactly called as derivative at a point. Derivative at a point, because your full focus will be for that point C. Now you have to, this is exactly you have to study in class 12th. In class 12th, we will be doing derivative at a point. But now for this point, we are going to learn how to find the derivative for all points. So basically whatever question we are going to deal, left hand derivative will be equal to right hand derivative. Basically whatever question you are going to deal here, left hand derivative will automatically become equal to right hand derivative. Now I am asking one question from Pooja, Gautam, those who are present here, that if LHS equal to RHS, then which side you can take? Which side you can take? Means if LHS equal to RHS, what does this means? That means left hand derivative equal to right hand derivative is there. That means can you take any of the side, or every time you have to take both the side? Can you take any of the side, or every time you have to take both the sides? Just one single point. Can you take any one of the side? Because LHS equal to RHS, we can take any one of the side. Because LHS equal to RHS means the both sides are equal. So we can take any of the point. Or you have to take both the sides every time. Very good, Gautam. One side. Very good, Danish. So exactly any one of the side if we are going to take, it is more than enough. Okay, so here basically what we are going to do, we will say that it is differentiable. We will say that differentiable or derivative, it is exactly, it can be derived from any one of the side, and we just have to use any one of the side. We just have to use any one of the side for this part. So now let's see how to use this side, because we are knowing, but basic formula first I am writing. What is the basic formula? Left and f dash c. So left side or right side, you are going to take which side is your priority. But for differentiation, you can take any one of the side. If left hand derivative is equal to right hand derivative is given to you, that means you don't have to prove every time that left side equal to right side. So it is already given to you that left hand part is equal to right hand part. Already given to you. Then only one work you have to do. You have to take any one of the side. Any one of the side and solve the question. Now what are the two sides? The two sides we can use is f dash c equal to limit h tends to 0 f of x minus h c minus h minus f of c by minus h. Either you can use this formula, which is left hand part of the derivative, or you can use this formula, which is right hand part of the derivative. So since left hand part equal to right hand part, it is totally up to your convenience which one you want to take. Now you tell me which one I should take to solve the next question. Which one I should take to solve the next question? Which one you feel is comfortable with? Left side or right side? Okay, so that I can use it and solve and at least solve one question. Right side? Okay, Gautam. I'm going to take your words. I'm going to take right side. Thank you, Gautam. So now your first question for today is a simple question I am taking for solving, and I am going to use right hand derivative, this part. So Gautam is very clever. He has taken right hand derivative because in the denominator part h is plus. In the denominator part h is plus, and now we are going to use again and again this formula, so that this formula will be feeded in your brain very nicely. Okay, we don't have to prove LHD means left hand derivative equal to right hand derivative. That is in class 12's portion. Now we are only going to take any one of this side and use it. Okay, the first question is, everyone focus in the question. Let f be a real valued function defined by f of x equal to x square plus 1. Find f dash 2. So they are telling that it is differentiable and you have to exactly find f dash 2. So now how to solve this question? First, they have told to find f dash 2. So here instead of c, which point is there? Instead of c, which point is there? Instead of c, 2 is there. So first we have to find f dash x. You know first what we have to do? First we have to find f dash x. So what is f dash x? First check that one. F dash x, how to find? F dash x is nothing but differentiation of f of x. Differentiation of f of x function. Now how to write? We are going to write it as limit h tends to 0 f of. First we are going to use the formula. Because here they have told for c 2. F dash 2. So since they have told for f dash 2, so we are exactly going to substitute 2. Initially we used to directly differentiate with respect to x and we used to put the 0.2 value, but now we are not going to do that. Fine. So we are directly going to use for 2 so that our burden will be reduced. Why we are going to take it again and again? One time itself we will solve it. So we are going to write here 2. So 2. So now what is the formula? F dash c will be equal to c plus h. So here it will become 2 plus h minus, instead of this formula, you see the formula and just you have to substitute. You see this down formula. Gautam told me to use this formula. So I am going to use this formula. Since Gautam told me, ma'am, you use this formula, so I am going to use this formula. In this is exactly right hand derivative part of it. So now how I am going to use right hand derivative part? One more time I am writing. Here it is exactly f dash c. They told in the question find f dash 2. So now we are exactly going to write the formula. Limit h tends to 0 f of 2 plus h minus f of 2 by h. Check here the value. Instead of c, what we put? 2. So everything is same. Everything is equal to right hand derivative. Only where c was there, I replaced c by 2. Only where c was there, I replaced c by 2. Now what is your function? Now just focus here into the next important point. Your function given to you is f of x equal to, so I am doing my homework here, f of x equal to x square plus 1. For solving this one, I am coming here to let you understand one very important point. So here f of x is written, so f of x equal to x square plus 1 is there. Now instead of f of x, if you are going to use 2 plus h. So now instead of x, what is written? 2 plus h. Then what will happen? Here instead of x, 2 plus h. So wherever x is there, it will become 2 plus h whole square plus 1. Now f of 2. F of 2 means what? Wherever x is there, now you have to put there 2. So 2 square plus 1. I want everyone to say you have understood this part or not. This is exactly the crack point. If you are going to crack this part, means over. Story is complete over. This is called killing the question, killing the story here in one shot itself. Good evening, Manish. I hope you might have understood this part. When f of x is x square plus 1, f of 2 plus h means instead of x, what you have to put? 2 plus h s square. Here f of 2 means 2 square plus 1. 2 square plus 1. Come on, give me a nod that you have understood this point. Now you have to just substitute f of 2 plus h. So here it will become limit h tends to 0. F of 2 plus h is there. There you are going to write what? There you are going to write 2 plus h whole square minus f of 2 will become 2 square plus 1 and down h will be there. Now next step, limit h tends to 0, 4 plus h plus 4h minus 4 minus 1 by h. So now here plus 4 and minus 4 will get cancelled. Are you understanding? So here plus 4 and minus 4 will get cancelled. Plus 4 and minus 4 will get cancelled. Here it is going to be 4 plus h plus 4h is there, and here it is going to be 2 square plus 1 is there. X square plus 1, so 2 square plus 1 is going to come. And here I think I missed 1 plus 1 here. Okay, plus 1 is here. So here it will be plus 1 also will be there. So plus 1, and here it is minus 2 square plus 1. So this part is going to have plus 1, this plus 1, and from here you are going to get minus 4 minus 1. So it is going to get cancelled. So now you have what? Now you have what? Now you have h square limit h tends to 0. Now take h common, h plus 4 by h. Now this and this will get cancelled. Now you substitute h tends to 0. Then it will become 0 plus 4. So overall answer is coming as 4. Overall answer is coming as 4. Overall answer is coming what? Overall answer is coming as 4. I want everyone to quickly tell you have understood or not. If you have not understood, I am going to again explain this point. But don't sit silently. Say you have understood or not. This batch, no one is interacting. Now come on, quickly tell me you have understood or not. Correct only, Gautam. Very good, Pooja. Super. So only two students are there. They are very active and very explaining. Pooja, Danish, Shreya, where are you? Anila, where are you? Kritika, where are you? Don't sit silently. Speak. Say you have understood or not. This is a very important, crucial questions. Okay. So you have to handle it very safely, very cleverly. So we are going to go for the next question and let's see how to check the next question out. Okay, Anila, understood? Now next question, beta. Function is given to you as it is real valued function. Algebraic functions are real valued function only. Okay. I am just generalizing the statement. Algebraic functions are real valued function. Now look here. What is given to you? X square plus 4x plus 3 is there. Now you have to find f dash 1. You have to find f dash 1 and f dash 3. Miss, if one time you have to find derivative of 1 and then you have to find derivative of 3. Understood, Saranya? Good evening, Saranya. Hi, Michael. Saranya, I am very disappointed. First time in this 3 years, I am so much disappointed from you. I am unable to trace out you are completing the contents or not. Very soon I am going to arrange one meeting with all of you. Don't worry. Very soon I am going to meet with my children, because I am planning for some offline classes. Thereafter, because now that coaching is almost ready, so we will start our offline classes now. Now look here, first thing is limit. Now first I am going to find f dash 1. For f dash 1, what you have to write? Limit h tends to 0, f of 1 plus h minus f of 1 by h. This formula, because okay, parabola and other chapters, beta, ellipse and hyperbola, finish that part. Saranya, but derivative is that thing which is going to come in class 12th. So now derivative, after this, whatever two important chapters are there, na, derivative is there, and after that probability is there. These two chapters are born for class 12th. So please kindly, I want that old Saranya back on fire in that. I want that Saranya back, because I know what Saranya is capable of. So once she will be coming, she will give tough competition to all. So I know that Saranya. So I'm really wanting Saranya to be back with me. I'm missing her a lot. I miss that attitude Saranya is having. Very good, super. But I want Saranya to be back with me. For these type of chapter, I want her to give the answers like this. Now look here. First thing is that f of 1 plus h is there. So now we are going to do our work. When f of x equal to x square plus 4x plus 3 is given, now f of 1 plus h is there. Now wherever x is there, now you are going to replace x with 1 plus h. So what it will become? 1 plus h whole square plus 4, again x is there, so it will become 1 plus h plus 3. Now f of 1. Now wherever x is there, it will become 1 square plus 4 into 1 plus 3. So this is exactly the 3 type differentiation is there. Okay. Now shall we start solving this question? Because now we have done our major work. Now we just have to substitute and solve. So limit x tends to 0. If before me my children will solve, it will be matter of proud for me. So f of 1 plus h. F of 1 plus h, I am going to substitute by that formula. It will come 1 plus h whole square plus 4, 1 plus h plus 3 minus bracket I am going to take 1 plus 4 plus 3 by h. Now limit h tends to 0, this one will become 1 plus h square plus 2h plus 4 plus 4h plus 3 minus 4 plus 1 5, 5 plus 3 8, so minus 8 by h. So now just count and check this one out, anything to get cancelled. Limit h tends to 0 and 1 plus 4 plus 3 8 plus h square plus 6h, 2 plus 4 6h minus 8 by h. So here plus 8 minus 8 will get cancelled. Now limit h tends to 0, take h common, it will become h plus 6 by h. So answer will come as 6. Anyone solved and got the answer? CB, good evening CB. Yes, so now f dash 1 is coming as 6. Absolutely correct. Absolutely correct. Answer is absolutely correct. Correct, Saranya. So we have to replace beta. We have to replace x, because here we are not proving left hand derivative equal to right hand derivative. Here one simple work we are doing, Saru. We are exactly differentiating at a particular point by considering that the derivative exists at that point. By considering that the derivative exists at that point. So left hand derivative equal to right hand derivative not proving, we are checking any side of the derivative we are taking and we are just finding the value. We are considering the derivative already exists. Okay. So now here the next question, again for the next question, please kindly solve before me. I will be very happy. Now look here, again same thing, but here f dash 3 is there. Now that means limit h tends to 0, f of 3 plus h minus f of 3 by h is there. So now here instead of 1, what you are going to write? Here f of x equal to x square plus 4x plus 3 is there. Now beta here it will become 3 plus h. So it will become 3 plus h whole square plus 4 into 3 plus h plus 3, and this part is f of 3 equal to 3 square plus 4 into 3 plus 3. So here it is exactly going to be written as limit h tends to 0. This part is coming as 3 plus h whole square, 3 plus h whole square plus 4 into 3 plus h plus 3 minus 3 3s are 9, 9, 9, 9, 9, 12, 21, 25 by h is there. So now we are just going to substitute and check. So r of minus 3, what is the value from that side? Gautam, what is the value? Shreya, Saranya, Shreya, Pooja, what is the answer going to be, beta? So limit h tends to 0, 9 plus h square plus 2 3s are 6x plus 12 plus 4h plus 3 minus 25. Now come on, count this one. 9 plus 12 will become how much? 22, 22 plus 3 will be 25. 25 by h will be there. So limit x tends to 0, limit h tends to 0, 25 plus h square plus 6 plus 4 10h minus 25 by h. So this and 2 will kill each other. So limit h tends to 0, we will take h common, it will come h plus 10 by h. Cancel. What is answer going to be? F dash. Hey Pooja, super, I got jackpot. First, before Gautam solved and then Pooja solved. Very good, very good. Gautam, Pooja, Shreya, thank you for giving me such a nice moment. So before me, if you all are solving now, me solving is a different thing. When you are solving means I feel very proud. So it is 10 answer. Very good. Well done for going to this level. Aha, super. So I think my team is back. Shall we go for next question, please? Shall we go for next question, please? Now go for this question. Now you have to find the value. F of x is given to you. F of x is given to you and it is coming as 2x square plus 3x minus 5. Okay, and at x equal to minus 1. So at x equal to minus 1, it is derivable at x equal to minus 1. It is derivable, the function is derivable, the function this is derivable at x equal to minus 1. Now you have to prove that f dash 0 plus f dash minus 1 equal to 0. Will we be able to prove this one? Is it a very big deal to prove? So first is derivable. Already they have given derivable. So why we are going to waste our time and derive it? So already it is given, it is derivable. So since it is given, it is derivable, we don't need to derive something. We just have to directly put the value and directly find the value here. So no need to waste time. So first we will find f dash 0 and then f dash minus 1 and substitute it, and we are going to check that it is going to come 0 or not. Now come on, let's see who is going to get it first, that it is coming 0 or not. So we have to prove this one. Is it going to come 0 or not? So first we are going to take f dash 0. So here it will become limit x tends to 0, f of 0 plus h. Since here 0 is there, it will become 0 plus h, f of 0 by h. Now here wherever x is there, we are going to write there 0 plus h. So here it is going to be 2, 0 plus h whole square plus 3, 0 plus h plus 5 minus 2 into 0 square plus 3 into 0 minus 5. Okay. H. Now it is going to be 2h square plus 3h plus 5 minus, this is 0, 0, this is minus 5 will become plus 5 by h. Is it going to be correct? Because h is minus 1. Okay, f dash 0 we are going to substitute. So since f dash 0 we are substituting, is it going to be coming as f dash 0 is coming as 3? F dash 0 is coming as 3 because here 2 is there. So 0 plus h, so it is going to be 0 plus h whole square plus 3h minus 5. Okay, minus 5 plus 5 is going to kill each other. So minus 5 plus 5 is going to kill each other. So minus 5 plus 5 is going to kill each other. So limit h tends to 0. Very good, Gautam. So h we are taking. So 2h plus 3 by h. So answer is exactly going to be 3. Very good, super. So f dash. Now can you tell me what will be the value of f dash minus 1, limit existing for f dash minus 1, because I know my children can be able to find now. So here you have to put, instead of c is there, Danish you proved 0, super Danish. So now look here. So here what we are going to do is, we will be substituting that part as minus 1 plus h minus f of minus 1 by h. So this is what you have to substitute with. So f dash minus 1 equal to limit h tends to 0. It is going to come as 2 minus 1 plus h whole square plus 3 minus 1 plus h and then minus 5, and this side it will be exactly minus 1 is there na. So minus 1 is there, so it will become 2 into minus 1 whole square plus 3 into minus 1 minus 5 by h is there. So it is going to be 2 1 plus h square minus 2h minus 3 plus 3h minus 5. It is going to be coming as minus 2. It is going to be coming as plus 3. And it is going to be coming as plus 5. So minus 5 plus 5 already gone. Now here h is there. Limit h tends to 0 is there. So now limit h tends to 0. Limit h tends to 0. It is going to be 2 plus 2h square minus 4h. And here it is going to be plus 3h, plus 3 minus 3 gone, and here it is only going to be plus 3h minus 2. So plus 2 minus 2 again gone, h is there. So we are going to take out 2h common. Limit h tends to 0, 2h common, so it is coming as h minus 2 by h. So this h and h cancel. It is going to come as minus 4. Is it coming as proof, Saranya? Super. It is coming minus 4 for me. Did you got also minus 4? So now we have to prove it as minus 4 is coming and here 3 is coming. So that means I killed the problem. My children have exactly done it correctly. So plus 3h is there. So I failed to write that plus 3h. So only I got this nonsense answer. So it is going to come as 2h square minus h by h. Got it, beta? So when limit h will be tending to 0, h will be there, it is going to come as 2h minus 1 by h. So it is coming as minus 1. So now f dash 0 is exactly coming as f dash 0 plus 3 f dash minus 1. So exactly it is coming as f dash 0 is coming as 3 plus 3 into minus 1. So it is coming as 3 minus 3 equal to 0. 3 minus 3 equal to 0. Very good, Saru. Gautam proved 3 minus 3 is coming as 0. So answer is exactly 0 proved. So now we are going to go for next question. Now I think, will you be able to solve this question or not? So I am going to tell you, you have to find the derivative of x to the power n. You have to find the derivative of x to the power n. Can you do it? You have to find the derivative of x to the power n. Very good, Saru. But by first derivable method, how we are going to do? By first, we are exactly going to differentiate it by using this derivable method. First principle, how we are going to use? How to use the first principle? So first principle method is the same method what we are going to do. Here we are going to write differentiation of f of x. So now f of x is exactly getting differentiated. So here we are going to write limit h tends to 0 f of x plus h minus f of h by h. F of x plus h minus f of x, minus f of x by h is equal to 0. So this is what only we have to do. And this differentiable part, very good, Saru. That is correct formula. So now Saru is back. So limit f of x plus h minus f of x by h is there. So now x to the power n, Pooja, Shreya, start solving, beta. If f of x is equal to x to the power n, now here f of x plus h to the power, f of x plus h is there. So it will become x plus h to the power n. So when f of x is there, it is coming as x to the power n. Now f of x plus h is there, so it will become f of x plus h to the power n. So here we are going to write, apart from this we are going to write x plus h to the power n minus x to the power n by h. Now beta, one formula was there. That formula was limit x tends to a, x to the power n minus a to the power n by x minus a, then it will become n a to the power n minus 1. This is the formula. This was the formula which we were using. So limit x tends to a will be there. Limit x tends to a, correct only Saru. So limit x tends to a is there. So x to the power n minus a to the power n by x minus a is nothing but n a to the power n minus 1. So this formula from limit was there. This formula from limit was there beta. So here also we have to convert it into this formula. So here we can add h here both side. So it is exactly going to come as x plus h. So you don't have to worry about it. You can take only h because x can be added on both sides. So here this will come limit x tends to 0. Okay, here it will be x plus h to the power n minus x to the power n. Only one small work you have to do in denominator, add x and subtract x. Now it is coming into the same format. But here one big problem is there. Here it is written that x tends to a. X tends to a, and here it is coming as h tends to 0. Here you have to remember one thing, that x is exactly there. So x part means x plus h, x, here it will become x. So x plus h will be tending to x. So that part is, you can do one thing. You can write this limit in shortcut form, that add x on both sides. So it will come x plus h tends to a, because when limit, just see this one, limit x tends to a is there, then x to the power n minus a to the power n by x minus a is there. This formula will be there, then only we can solve. So now here, instead of x, what is there? X plus h. So now this x, so we can write here x plus h. Since here x plus h is there, so we wrote x plus h. Now x is tending to a, so x plus h will be tending to x, so x plus h is tending to x. Now we got the entire part of it. I just added x on both and right side of the derivable. So there, and both side of the limit. So we got this point. Now we can very easily be able to write it as n x to the power n minus 1, because the derivation of this part is n a to the power n minus 1. So instead of a, what is there? X. So instead of a, x is there. So we are going to write it as n x to the power n minus 1. N x to the power n minus 1. This is a very important point of it. So now we are going to prove one more. Let's see how you are going to do it. Proof for this one. Differentiation of e to the power x. What answer is going to come? Differentiation of e to the power x. Differentiation of e to the power x by first principle. Differentiation of e to the power x by using first principle. Differentiation of e to the power x by using first principle. Let's see what differentiation we are going to get. Again same method we are going to do. We will write differentiable. This is nothing but f of x is equal to e to the power x function is given to you. Here function is given to you is f of x. What answers are? E to the power x. Absolutely correct beta. So now differentiation of e to the power x or differentiation of f of x will be written as limit x tends to 0 f of x plus h minus f of x by h is there. So now here limit h tends to 0, here e to the f of this is there, so f of x is e to the power x, then f of x plus h will become what? X plus h will become e to the power x plus h. So wherever x is there, there it will become e to the power x plus h. So here it will become e to the power x plus h minus e to the power x by h. So first work is, we are going to write limit h tends to 0 e to the power x into e to the power h minus e to the power x by h. Why? Because here this one I am writing e to the power x plus h will be written as e to the power x e to the power into e to the power h. Why? Because if a to the power x plus y is there, it will be written as a to the power x into a to the power y. So when same base will be there, power will be added. So here base is a, so power got added as x plus y. So now e to the power x we can take common. E to the power x we can take common. So limit x tends to 0, h tends to 0. Here e to the power x is constant, it came out. Now we have e to the power h minus 1 by h. So now we know one formula, and that formula is limit h tends to 0, e to the power x minus 1 by x equal to 1. So this is the formula which we have used in limit. This is the formula which we have used in limit. So now this directly will become equal to 1. So now this will become e to the power x into 1 equal to e to the power x. This is exactly direct application. Okay. So one more indirect application is there, that is using exponential formula. So exponential formula is, you know, e to the power x formula is, so here this formula, so directly I use limit h tends to 0, e to the power x minus 1 by x equal to 1. But one more formula of exponential is there, e to the power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, like this. So one time when we are not using this formula, then we can substitute this part and we can solve. It will be solved also. It will be solved by that method also, but that method will be very, very lengthy. So here one time you have to substitute. So one step only I am showing you. If you will be going by that method, how much lengthy it will be. Limit h tends to 0 will be there. E to the power x plus h minus e to the power x is there. So just do one thing, that is take out e to the power x, so we have taken out. Now you have e to the power h minus 1 by h. So now e to the power h formula is what? E to the power h formula, I told you this one. So it will become 1 plus h by 1 factorial plus h square by 2 factorial plus h cube by 3 factorial, so on, minus 1. So plus 1 minus 1 got cancelled, and here h is there. So limit h tends to 0, e to the power x is coming. Now here h plus h square by 2 factorial will go on, and down h is there. So just take out one h common. It will come out with e to the power x, and there it will become 1 h by 2 factorial plus h square by 3 factorial. Since one h you have taken out, now this h and h will get cancelled. Now if you will put h equal to 0, no problem, because this 1 is there. So overall answer will come e to the power x. Overall answer will come e to the power x. So this is when you will use exponential formula. So if you are knowing exponential formula, or you are knowing this formula, you will be able to use first principle, and you will be able to solve the question nicely. Now another question I am giving you, use first principle and solve this question. A to the power x, f of x is equal to a to the power x. I know you will directly write the formula here. A to the power x, beta. A to the power x. Use the formula and write a to the power x. Use the formula and write a to the power x. One differentiable formula I am going to give you. Limit of x tends to 0, a to the power x minus 1 by x. There is a formula for it. A to the power x minus 1 by x formula is log EA. It will be exactly coming as log EA. So this formula is there. This formula is there. If you know this formula, you will be able to handle the question in no time. Now what is the answer? A to the power x, e to the power log EA. E to the power a or a to the power e. What is there? A to the power x, e to the power log EA. Correct only, Gautam. Let's see how to solve this question. So it is going to be limit h tends to 0, f dash x equal to, now here it will become f of x plus h minus f of x by h. So now limit h tends to 0, it will f of x plus h will become a to the power x plus h minus a to the power x by h. So here limit h tends to 0, a to the power x take common, it will become a to the power h minus 1 by x. So now I told you one formula. That formula value is a to the power x as it is, but this part I told you this formula, limit x tends to 0, a to the power x minus 1 by x is log EA. So here limit h tends to 0, a to the power h minus 1 by h. This part formula directly we are going to write. So why to write one more step? It will become a to the power x constant coming out. Here it will become log base EA. So this derivable part will be there. Absolutely correct. So I am going to keep it till here. I just use this formula beta. A to the power x is also coming as, now this formula is also existing as a to the power x will be written as e to the power x log a. So if you don't want to solve by this method, you can convert it into exponential also, you will be getting the answer. So here one small change I am doing and I am proving you this point. Now look here, limit h tends to 0 is there, a to the power x is there. Now a to the power h can be written as e to the power h log base EA minus 1. So again exponential formula we can apply, again 1 will get cancelled, a to the power x, here it will become 1 plus h log a by 1 factorial plus h square log EA whole square by 2 factorial and so on, and minus 1. So plus 1 minus 1 will get cancelled, h will be there, limit h tends to 0. Now here from here you just take out log a. The moment you will take out log a and h, what will happen? Limit h tends to 0, log base EA and h taken out. Already a to the power x is there. So now this part coming out, now 1 plus h log base EA by 2 factorial, so on, by down h is there, this and this will get cancelled, put h equal to 0, all will become 0, answer will come this. So no big deal, we can convert a to the power h as e to the power h log a. So if you know these type of derivatives, you will 100% be able to solve the question in no time. So I am going to keep it till here. Next class we will be solving some more typical questions. Bye for now. Good night everyone.